So which tank cleaner is the most water efficient? Now this is a question we get asked an awful lot at the spray nozzle people, and for fairly obvious reasons. Water saving is a big concern for most businesses, and any businesses that are involved in tank cleaning, water can be quite a significant cost. You've got to buy the water in first of all, then you've got to pump it, and then you've got to heat it, and then you've got to dispose of it. And disposal of contaminated water from tank washes can be quite expensive. Indeed, so much so that in some industries, like water intensive industries such as dairy, it can be one of the most significant overheads, the overall cost of water. So saving water is a good thing. So which type of tank cleaner is most water efficient? Now there's a short answer to this question, and the short answer is high impact tank cleaners. Generally, the higher the impact tank cleaner, the more water efficient it's going to be. However, there's some nuances to this. So there's a slightly longer answer to that question, and this is what this video is actually about. So hopefully to give you some insight into making good decisions about which tank cleaner to use. So first of all, let's step back a bit and look at what makes up a clean. Okay, any cleaning action, any cleaning operation is made up of 4 key components. This is mechanical action, which is the physical scrubbing action of the clean, so scrubbing off the residue. Heat, so the hotter the cleaning fluid, the better it will break down residues, so the hotter the better. Time, now obviously the longer you actually spend cleaning something with any given cleaning system, the more clean it's going to get. And then chemical action, and this is the solvent quality of the chemicals being used in the clean, so the solvent action of it breaking down the residue. Now any cleaning operation will be a combination of these 4 elements. If you reduce the parts, one part or more than one part, so you have to compensate by increasing the other parts to make sure that the overall clean is still effective. Now you'll note that water isn't one of those components. So we need to think about this. Where does water come into this? Water is used in pretty much every cleaning action. So where does the water consumption fit into that 4-part model? And there's 2 components that it actually fits into. Okay, so firstly, water is the main solvent used in almost all cleaning actions. Now sometimes we don't think of water as a solvent, but in actual fact it's known as the universal solvent. More things dissolve in water than any other chemical, and it is by far the most common solvent used in any cleaning action. Now you may add solvents to water to improve the cleaning action, but nevertheless the chemical action component of most cleaning operations is largely made up of water. So the chemical action component is definitely part of water consumption. The other part of the 4 components that makes up water is time, because all cleaning systems, especially tank cleaning systems, all the time that they're on, they're using water. They're water driven, they're using water as the cleaning medium, or using water to deliver the other solvents to the tank wall. So all the time they're on, they're using water. So water consumption is essentially a function of the chemical action component of the clean and the time component of the clean. So if we want to reduce water consumption, therefore we need to reduce chemical action and time. So naturally, if we want to keep the clean effective, we need to increase either heat and or mechanical action. Now we'll leave heat aside for one moment, because that's kind of its own separate entity, and we'll assume we're keeping heat stable. So if we keep keeping it at the same sort of temperature, then we're left with mechanical action. And so in order to reduce water, we need to increase mechanical action. And this is why the general rule that higher impact, higher mechanical action tank cleaning devices are more water efficient. But there are some exceptions. So rotary jet cleaners, which are the high mechanical action jet cleaners that we have, they must go through a set cleaning cycle in order to deliver their cleaning action to every part of the tank. This is unlike spray balls and spinners, which are low mechanical action tank cleaners and so inherently less efficient. But if the residue is very, very light, the spinners and spray balls will provide instantaneous coverage to the whole tank, or near instantaneous coverage to the whole tank. And if that residue only takes, say, a couple of minutes to actually come off, then the rotary jet cleaner in the same tank, even though it may be more water efficient overall, still has to maybe go through a 5, 6, 7 minute, 10-minute cleaning cycle just to get its cleaning to every part of the tank. Therefore, it's going to be less efficient overall, because it has to go through that set cleaning cycle, unlike the spray balls and the spinners. So there's an exception there. High pressure cleaners, and by this I mean the high pressure cleaners running at 100 bar or so, as opposed to the mid-range jet cleaners, rotary jet cleaners running at, say, 10 bar. High pressure cleaners tend to have quite a short range of their cleaning jets. So when we're looking at very large tanks, these high pressure jet cleaners may need to be moved around within the tank. So, and they have to go through their set cleaning cycle in each stage of the clean. Now, apart from the hassle of actually having to move them around inside a large tank so that their relatively short jets can actually reach each part of it, you've then got to double up the cleaning cycle time. So you're doubling up or trebling up the time component, which is a key component in water consumption. So in very large tanks, it can often be the case that the very high pressure jet cleaners, the 100 bar jet cleaners, are actually less water efficient than the 10 bar rotary jet cleaners running at medium pressures, precisely because you have to do multiple cleaning cycles to move them around within the tank to get an overall effective clean. So there's an exception to the rule there as well. Now, obviously, any water savings that you do achieve through increasing the mechanical action through having superior tank cleaners needs to be offset against the additional energy needs and hardware associated with running those higher pressure, higher mechanical action systems. And this is particularly true when it comes to the high pressure systems, the 100 bar type systems, because they're going to need expensive pumps and expensive pipe work and all the rest of it. It's less so, but there's still some truth in it for the mid pressure rotary jet cleaners. You still need to take into account those additional hardware and piping costs when compared to spinners. So even though the overall water savings are going to be there in terms of clean water used per cycle, that may be offset by the additional hardware costs as well. So again, each tank cleaning situation is unique and needs to be analysed, but this video hopefully gives you some general rules with which to start making decisions. Now, if you need any advice on any of this, then come and talk to us. We're the experts. We've seen every single type of tank cleaning situation you care to imagine, and can advise you accordingly. Now, I hope you found this video useful, and I hope that starts to answer the question, which type of tank cleaner is most water efficient.